preview. Couple of things to keep in mind, because now we're going to go back to some things with not even just log, but like growth and decay a little bit too. So we're going to kind of have to remember some of this. So all right, preview for quiz 2. Now some of you probably aren't going to think about this info without looking at the graph. So if I do this first one and make sure that both your log and your minus 4, in this case, are in parentheses, so it looks just like the problem itself. When I go to graph this, now I might get a little idea of what's going on just by looking at the graph, but I'm going to get more of an idea maybe of what's going on from the table. Well, there's one helpful thing I get from the table. What's my x-intercept going to be? Number 1, numero uno on the quiz preview.
5, 0.
Okay, 5, 0. Okay, it's a coordinate point, so we want to keep it as such. Okay, I don't want to just put like x equals 5, because that's a vertical line. Now, domain and range, here's where you've got to be careful. So here's just a suggestion whenever you're doing a log or a growth and decay problem. What's the shift on this problem? Right 4, okay? When we're doing logarithms, it's the domain that's going to be moving around. Because if I look at the graph, and I don't see it real well on here, you could be tempted when you do your domain, or if you look at the chart, to think, oh, it's like from 5 to infinity, because that's where the numbers start. But that's not what happens, because a typical logarithm, so like just y equals log x, is going to have a domain from 0 to infinity. That left or right shift is the exact number your domain is moving. So if it says you're shifting right 4, your domain is shifting right 4. But some of you are going to say, but it says error at 4. How can it be at 4? Again, it's going to get really close to 4, so let's take a look at it a little different of a way. I'm going to just change my table here for a minute. And instead of having it count by ones, I'm going to have it, I'm going to have it count by 1/10. I'm going to take a little smaller of a look at it. So when I get back to that area around 4 that I was looking at before, watch what happens. Oh, there are numbers in the 4s. It's when it literally gets to 4 that there's an error. So by looking a little bit more detailed, I can visually see that, but the whole key comes right here. If you see a right or left shift on a log, that shift goes hand in hand with your domain. You wouldn't even have to graph it really to tell me the domain, I would hope. Okay? So, yep, and it's always going to be heading off to positive infinity for my domain. So then, for my range, that's going to be the same every time. Because my graph, when it hits this spot, starts to go down forever to negative infinity. Because if I look at the graph, even though I can't see it here, this is going to keep coming downward and just hug that asymptote. And then heading the other way, this is going to keep increasing. So, range always the same. Domain can shift if there's a left or a right shift. And I'm going to zoom this out just a little bit so we can actually see everything that's going on. So when we get to part 2, it says rewrite into logarithmic or exponential form. Okay, this first one is in log form, and I want to get it to its exponent form. What would that look like? If I was trying to set this up so I could solve it, what would it look like? Give it a shot. 2 to the x equals 64. Here's my base. Here's my exponent. Here's my answer. Now comes the fun part. We're going to go in reverse. I have 7 to the third equals y, and now I want to get it back into its logarithmic form. Here's where you want to use this as your example and say, okay, I know there's going to be a log here, and I've got equals. Now let's figure out how this all works. My subbase is the base of my answer. So my log will be 7. Let's see what else I knew. My answer of sorts turned into my exponent. So my answer what? And then this became my solution, my big number. 7 to the third equals y. So once I know my form this way, I can just kind of check back to make sure. 7 to the third equals y. 2 to the x equals 64. They're in the same format. So I'm going to make you think a little bit. Yes, thinking, I know. It can be scary. But once you know this format, you know them both. So as long as you've got one, you can kind of work your way through that way. Okay? Evaluate. Let me make this clear. Okay? Could you use change of base form on every single one of these? Yes. Do I assume most of you are going to use change of base form on all of these? Yes. But you have to show me how you're getting there. In other words, before you go and use change of base form, I want you to turn this into its exponential. So in other words here, okay, 4 to the x equals 16. Now I'm assuming that one you're probably going to know off the top of your head. 4 to what power gets me to 16? 2. Okay? If for some reason you went into panic and you just couldn't remember for the life of you what 4 to the what power is 16 tomorrow, remember, you could do a change of base on this. You could do, like we were doing earlier, you could say log of 16, log of your big base, divided by log of your subbase, and there the answer is going to be for you. So as long as you can set these up in their exponential forms, if you get stuck and you want to go back and use change of base, you can. I'm never going to know. But you've still got to be able to set these up, base, exponent, answer, before you use change of base. If you just write for like number 5, log of 81 divided by log of 3, okay, you've got to be able to make some of these transitions. Base, exponent, solution. Ooh. This is the one where if you're thinking about it for a minute, where when we're going from a whole number to a fraction, I know it's going to be negative. That's one thing that I know for sure. 2 to what power gets me to 4? 2. So 2 to the negative second, 2 to the second would be 4. By using the negative exponent, that gets me the inverse. That makes it flip. So if that thought process doesn't work well, I could do log to the 1/4 divided by log of 2, and I'd get that same answer out. So it still works. Oops, and I got the calculator in the way. Let me get it out of the way here. So that's how that one would work. Same deal going with 7. 9 to the x equals 1. Now I hope we'd know this one. Anything to the 0 power gets me to 1. But again, in case of panic, log 1 divided by log 9 with your change of base gets you there. Okay, same idea. As long as you can show me this, we're good. Any issues so far? Okay, how do I find the inverse of a logarithm? Switch the y and the x And solve for y. Okay, but I have a problem. I have a log base 5 stuck to my y. How do I tell it to go away? ln and e are inverses, but we don't have any ln or e's working here. All right. I'm going to turn both of these sides into exponents by using my base. Again, these are now exponents. So my 5 and my log base 5 are inverses. They cancel. And I have y to the 5x, not 5x. 5 to the x. That's an exponent. Yes, ma'am?
Were you multiplying both sides so far?
I'm turning both sides into exponentials. The 5 becomes my base. So it's like if you're doing x squared, I'm turning both the sides into like the squared. I'm turning them into the exponents.
Can you not switch the answers around? You know how you like flipped it when you wrote it? When you wrote x equals, or y equals 5x, and you flipped it?
What do you mean I flipped it?
Like
Oh, you mean right, like 5 to the x equals y?
Yeah.
Yeah, that's okay.
Okay, just for like...
Yep, that's okay. Gotcha. So next, we move into the stuff that we are just pounding away on here for the past couple of days. So this shouldn't take us as long, I hope. What's this multiplication going to become? Adding. So log of 2 plus log of w plus log of z. I'm done. No exponents, no fancy business. Now 10's a little more interesting, because you just told me multiply was add, so I got that part. So log 5 plus log of m, it would, because division becomes subtraction minus log of p. Nicely done. Now, don't treat natural log any different than you'd treat log. Rules still apply. So I'm going to do this at the start really similarly to what I did in 10. I'm multiplying these two together. So I've got the natural log of x to the negative second plus the natural log of y to the third. And then just like here, my division is subtract. Am I done? Not quite. We got a whole lot of exponents to swing around. And they become coefficients in the front. Notice I have no exponent left when I do this. That's where it's actually going. And once I've done that last step, then I'm good to go. So expanding doesn't seem to be an issue. Now I'm hoping condensing is not going to be, but we'll see. Okay. Condense, just the opposite of everything. Any coefficients you see get dealt with first. Once the coefficients are set, now we're going in reverse order. So now add becomes multiply. So I can either write this as log 4y squared if I want to put the two terms together that way. Or if you wanted to put log y squared times log 4, you could. But again, this would be the way it's prototypically written as an answer. You're just multiplying those bases together and you're done. And it'll be the same deal in 13. Swing those coefficients back up into being exponents. And what's subtract going to become? Divide. So my first term divided by my second term. And again, I could put ln's on both and just put them over each other as a fraction. But again, this is more typical the way that it would look. And then, of course, I got to throw a twist in. I mean, what fun is... Gets boring otherwise. So we're going to... It's just numbers working here. So the natural log of 4 to the 1/2 plus the natural log of 2 to the 5th minus the natural log of 7. But I actually want you to calculate what the values are. So 4 to the 1/2 power is the same thing as the square root of 4. So that's the natural log of 2. 2 to the 5th power, and it's actually an exponent this time, so don't just multiply them, would be natural log of 32 minus the natural log of 7. So then to finish, do it in pieces. Add becomes multiply, so 2 times 32 would be the natural log of 64 minus the natural log of 7 would make it a fraction. But again, if you do ln 64 over ln 7, that's perfectly acceptable.
You get it wrong if you just left with like ln and then 4.
You're going to get dinged for something there because if you don't simplify this down and then just keep simplifying it down.
Okay, what I did is I did ln and then I got 4 to the 1/2
Uh-huh.
times 2 to the 5th
Sure.
times 7, and then I solved that entire thing.
That's okay.
Oh.
Yeah, there's not an absolute with the order on things. If you want to do the multiplying part and then simplify these two, that's absolutely fine.
So you don't divide by the 7 afterwards?
You could, but since it gets kind of nasty, I wouldn't mark it wrong. If you actually put like ln to the 9 point whatever it is, I'm not going to get angry about that. Yes, ma'am. All right. 15 is the redemption question from quiz number 1. When looking at the function, is it growth or decay? Now, I'm assuming most of you will probably type that in the calculator. When you type it in, you find out it is growth. Oh boy. Why?
Because of the negative exponent, it reduces it, so it's for like greater than 1.
All right. Negative exponent, don't stop there. I'll ding you again. It turns your base into its reciprocal. I don't care if you call it flipping the fraction. I don't care. As long as you get through to me somehow that this became that, okay? That my base, the reason it's growth is that 4 right there, okay? That's what I'm looking for, an explanation of, you know, well, what happened, what occurred here to make it be that, instead of just, yeah, it's a negative, it's growth. No, okay? So make sure you either write this out for me, reciprocal, any of those words or phrases would be great, okay? Oh, deep breath as I flip. Okay, as far as graphing the functions go, I'm going to make the assumption, I know that's dangerous, that you can type this in on a calculator, plot some points, and get the graph. I'm more interested in what's going on down here. What's my shift in number 16? Close. Down 4. If it would have been up in the exponent, I'd have agreed. When we're doing, this is a growth and decay problem because there's no log anywhere. These are the ones where your range changes. That moved down 4. My range went down 4 with it. These are the ones where domain never changes. Okay, it's always negative infinity to infinity, but my range can move if I have an up or a down shift, which is specifically why this one was put on here. However, if I'm doing a logarithm like I am on 17, those are the ones where my domain changes if I'm shifting left or right, and the range never gets to move. So what in 17 are my shifts? Right 2 and up 1. But when I'm doing domain, that's left, right. So the only thing I care about shift-wise in my domain is, ooh, right 2. So my domain moved right 2. The up 1 you'll see when you graph it, but as far as the domain goes, it doesn't mean anything. And it doesn't mess with my range. That's the thing I wanted to stress here.
So for the first one, the domain never changes, for this one, range never changes?
Correct. And then again, 18's just talking about shifts. So what are my 2 shifts for 18?
Left 2, down 4.
Left 2 and down 4. That's all I need there. And then just to kind of give you a heads up on 19 and 20, because they're really similar in how they work. So I'll get you 19 up here. So I've got 1,000 bacteria. Grows 12% per minute. And we're trying to figure out when it reaches 1,800. So I don't know what this is. This is another one of those that I'm just going to plug into the calculator. And go until I'm like, okay, 1,800 looks like it's between years 5 and 6, and that's fine. Oh, it's 5 and 6 minutes, isn't it? Yeah, that's a lot different than years. I wouldn't, that's one of those. And then the only thing I'll mention on 20 is, notice they don't tell you how much money you got to start with. You get to pick. So if you, yeah, like if you put in 10 and it says how long will it take to double, then you're looking to see when it turns into 20. If you plug in 100, when does it turn into 200? So see, I'm going to be nice and finish this one off, at least on here for you, because I'm nice that way. Pick your own starting amount as long as it doubles. And that part would go in the calc.